Hello everyone, you are welcome back to the last part of the video. In this video we will be establishing the parameters that will be used to make the conclusion about the economy and the stability of a simply supported beam. In the last video we did the same for the fixed beam, so let's just go to the story plan. We will be using the same load, the same everything, just the support will be different, of course. So what you do is you click on the beam and then you can right click, then you go to update beam end condition, and then I will pick both ends are hinged. Before it is no hinges because there's no hinge. Now I'm going to hinge both ends, so click on both end. Now apply to selected beam. I only have one beam. Now it tells me that my analysis is going to be terminated, the analysis that we've done for the previous one, so click on yes. Alright, now you will see the hinge here. So this is the hinge at this end and the hinge at the other end. So this has now become a simply supported beam. By applying the hinges at the two ends, we've moved it from a fixed beam to a simply supported beam. Now we have to analyze it and we have to redesign it. So to do that, just go to analysis and then click on building analysis. We don't need to bother about the load combination and the all this and more. Just go to analysis directly and then click on beauty analysis. I want to design my beam reinforcement and then click on building analysis. Okay, so all these are satisfied. Just click on OK and then I can close this. You go to post analysis and then let's see the beam reinforcement design. And now you can double click on this. Alright, so this is the reinforcement we have. You can see that the top reinforcement is 2y16 while the bottom is 3y25. Okay, so just as we did in the last video, I want to establish it so that I can have the same diameter of rebar, because that is what is going to make the comparison easier. So I'll change this from y25 to 16. So I will reduce the diameter and then I will increase the number until it passes. So it has passed. Now I am having 7y16 at the bottom and 2y16 at the top. That tells me that for this beam I will need a total of 9y16 for the reinforcement. Okay, so that is fine. I can close that. And then another thing I have to check is the beam capacity report, just as we did in the last one. So I click on the beam capacity results, click on OK. Now I am going to check the demand shear force and the shear force capacity. The demand shear force is 11.3 while the capacity is 57.2. This is slightly different from what we have in the fixed supported beam, but at the end of the day the ratio of this ends up to give the same thing, which is 0.2. So I will make my comments on this at the end of the video, but not now. So let's close this. So close this. Now the next thing to do is to check the deflection after 5 years and more, and also check the crack weight after 5 years and more. So I click on this and then you can see deflection and crack check. Okay, so 5 years or more is the loading time. Okay, and then member do not carry sensitive load, check deflection anyway, and then click on OK. The interior, that's what I'll be using for the crack width. So you use interior. If you want to use exterior is 0.1, I think. No, it's 0.2, sorry. So I'll be using the interior, so just click on OK. Alright, so now let's check the deflection. The total deflection after 5 years will give me 16.088. For the simply supported beam, I'll be having a deflection of 16.088 at the end of 5 years or beyond. So after that, I will have to check the crack width as well. So what do I have for the crack width? The crack width is 0.16 millimeter, and that is less than 0.4, so it is adequate. So the value I'm concerned about is what I have here, which is 0.16. Okay, so since this is done, I can just close this and then we can make the comparison. To make the comparison easier, I have make the result here. So let's just open that. Let me widen this a little bit more. So now let's make the comparison, the comment, and the conclusion. For the simply supported beam, the number of bars that is required is 9, and for a fixed beam I will need just 7 numbers of reinforcement to have that kind of beam. This tells me that it is more economical for me to use a fixed beam, because for a fixed beam I will be saving 2 lengths of rebar for each beam. So imagine having this kind of beam like 10 places. That means I'll be saving about 20 lengths of reinforcement in the whole structure. So it is more economical to design using a fixed beam condition than using a simply supported condition. So this is established. Now we can move forward to check the deflection at 5 years. The deflection at 5 years for a simply supported beam will give me 16.088. While that of fixed beam will give me 13.779. That tells me that the deflection of a fixed beam is even lesser than that of a simply supported beam. So in this case, I also want to go for a fixed beam. Fixed beam has the upper hand for this as well. Then for the crack after 5 years, simply supported we have 0.16, while a fixed beam we have 0.17. This is almost the same thing. Now for the shear demand and shear capacity ratio, for simply supported it is 0.2, and for the fixed beam it is also 0.2. So these are the same. But why are these the same? It is very simple. The reason why they are the same is because it has been designed. The purpose of doing the design is to make sure that the stability of the simply supported beam will be the same to that of fixed beam if the same condition of load, the same condition of span and everything are the same. The only difference is just in the support. You will see that the crack is almost the same as well, but the deflection is not the same. Now from the results that we've gotten, we can make our conclusion. The number one conclusion is that fixed ended beams are more economical to use. And number two is that if properly designed, the stability of a fixed ended beam and the stability of a simply supported beam will be equal. So this will bring us to the end of the review about a simply supported beam and a fixed supported beam concerning the economy and the stability. If you enjoyed this video, kindly give it a like, and if you are not a subscriber yet, make sure you give this channel a subscription. So if there is still anything you want me to review, you can put it in the comment section. I will definitely work on it, and I will make my conclusion using a well accepted software, maybe ProtaStructur, Start Pro, SAP 2000, or whatsoever software is best for the work. Till we'll meet the next time. Thank you.